meeting, you can always share the links to your guys, your friends, ask them to join, and then they can also benefit from this knowledge that all of us are benefiting from. So great. Hi guys, my name is Etete Etok again, and of course we are on the Ethereum Nigeria account abstraction series. Of course, we've had our first, our part 1 and our part 2, and today we are going to dive deeper into the third part of our account abstraction series. And of course, for those that attended, and of course, if you didn't attend, the resources are always available on our YouTube channel. So you can always go to youtube.com/@Ethereum Nigeria, and then you have access to all our resources, both the account abstraction series and a lot more. So without much ado, of course, we have a very esteemed developer in the house. Of course, he's going to take us on the last part of our account abstraction series. I'm so excited. And I hope you guys are also as excited as I am, right? Because I know we've actually learned a lot. Yeah, our lead was here on the first day. He did justice. He made sure we understood all the concepts. And then on the second day, we tried to do a hands-on. And then today, we are going to actually see how we can push this and do this on a live blockchain, right? So without much ado, join me as I invite, of course, our able speaker for tonight. He is a very talented developer, lots of experience. He has worked on a lot of projects also. So let's invite, of course, our speaker for tonight, our facilitator for tonight, Mr. Uche, to, of course, if you can hear me, Mr. Uche, please, the floor is yours.
Hey guys,
Yeah,
I was
hi,
really
awesome,
looking for
great,
who you
man.
were talking about. Uh,
I was talking about you, Yawa, Oga, Agba developer.
please, oh, everybody's learning here, especially me. Let's dive into it. Good day, guys. So, my name is Uche, and today, um, yesterday, our lead took us through what account abstraction is, and just like give us an overview and the architectural view of what account abstraction is, the EIP 4337, how it works, why we need it, and the benefits. So yesterday we went through hands-on on account abstraction, the entry point, deploying the entry point locally, getting the address. So what we'll be doing, so let me just share my screen real quick. I guess everyone can see my screen now, right? I'll take that as the yes. All right, so what we'll be doing, it's coming from okay, I can't take that as a yes now. Can you hear me? Can you see my screen?
Yes, awesome. We can see your screen and we can hear you clearly.
All right. So by no means am I the author of this tutorial I'm about to give out. I learned everything about coding this out and customizing it and deploying it to testnet. Everything from this video from Alchemy. There's this series of videos. So I'll just drop this link on the chat. So you could just have that by the side because I might not be an excellent teacher, but this guy is. So yeah, that's for one. And the code base for what we'll be talking about today is this. So now we have this over with, so we can now start like we can start diving down into the code base. So I think it took us um through the core components of EIP 4337. So our aim today is to have a refresher knowledge on EIP 4337, create a very basic wallet. If time lets us, we create a little bit advanced wallet. And the only thing that will make this wallet advanced is social recovery. So, this problem of losing your private key or your seed phrase and you can't access your account again. So that can be solved with social recovery. So this is what I mean by social recovery. You have some trusted friends that you have told your account should this out of these five trusted friends, if four of them come together and send you a message saying that I have lost authority over this account, give them the permission to reset the owner of the account. So that's what social recovery is, just like 2FA, but this time around with your friends. So the other is what I'll call a dead man lock. No, not a dead man lock. Let's just call it that. So it's just like inheritance. So as let's say as a father, and I want to give my child or will my child my wealth, and I happen to be a Web3 father, so I have a huge chunk of my assets on chain. So if I want to give my child this wealth, who it's most likely I would go to my um MetaMask, then take my private key um and maybe hide it somewhere within some years, or give it to a lawyer within some years, give it to my child. But when they usually say if you are not with the key, the account is not yours. You don't have the key, the money is not yours. So what if that lawyer misplaced it and someone else gets hold of my assets? So while I'm still alive, I am now a poor man, and my child will have nothing from me. So account abstraction can solve that in that I can specify in a logic in my contract that would release this account to a specified address, or would change this owner to a specified address, and at this certain given time, maybe in the next 50 years, in the next 30 years, that function can now be triggered to change the account. And without revealing private keys, the account is now going to be owned by my child. And I feel that's something very cool. And you can just be passing it on from generations to generations. So that's what we'll be looking at today. And a few of them will be coding them hands-on. A few of them are just switching branches, and we just test them out and talk about the code, ask few questions, and just have fun. So another full disclosure, I didn't write this code. I only watched the video, learned, built another uh smart contract account from the knowledge I've gotten from this, but I would be teaching with this, and we just proceed as we go on. So let's take it one after the other. So we'll be going over the things that have taught us before concerning the account generation, deploying the entry points, And just like a refresher for those that didn't get it earlier on. So, well, first of all, we know in account abstraction, we have the entry point, which the user operations are sent to. So the user operations is sent to the entry point. The entry point validates this user operations and see if it's profitable for the bundler with the configuration the bundler have specified. Then paymaster, if there's a paymaster, and after this paymaster then gets to the smart contract account, which is ideally now the wallet of this user, and executes the transaction. So now state change can be made on the blockchain. So I hope everybody understands this schematic, and I think that this is what we've been going through for the past 2-3 days now. So from this diagram, we first look at a user operator or user operation structure again, just as a refresher one more time. So yeah, down. So this is how a user operator looks like. So when we are sending transactions with a smart contract, using the smart contract account model, we are sending user operations. But when we are using our normal wallets, MetaMask, and the rest, we're just using transactions. So I want you to just look at this field and just remember what they are. We will not be manipulating them, just have them in mind. So we have the sender, person initiating this user operation. We have the nonce, the init code. If this contract have not been deployed, it will use this init code to call this factory to deploy this contract. So we have the core data, core gas limits, the verified gas limits, the pre-verified gas limits, the maximum fee per gas, the maximum priority fee, the paymaster, and the data. So the paymaster and the data just holds the address of the paymaster contract, and if there is a need for a data, then the data is appended as follows. Then the signature, just to verify that, oh yes, this user operation was signed by a key that can control our smart contract account. So enough of the boring talks. So let's look into this. So I'll zoom. Uh, so first of all, we are getting what we want to do now is create a very, very basic account. We'll talk about what is needed to be in an account and how the account works in general. So let's dive in. So first, we want to create a smart contract that we will call an account. So for this smart contract now, remember from our last classes, uh, when you are doing account abstraction, there is now an account and a key where this key is your MetaMask. That's your MetaMask or any kind of wallet you have. It knows that already. And the account is the smart contract. So now this owner is just the address of this key. That's the public key from this private key in your MetaMask. That's what the owner is. So when an action is to be done on this account, maybe to instantiate a withdrawal or to call up another contract to do something. So when that is done, what this wallet ought to do first is, oh yes, is this person calling me now? This key, should I respond to this key or should I reject this key? That means the person calling me now, is it the owner? Is it my owner or not? If it's the owner, then go ahead. If not, revert. But we'll be lazy for now. And as we proceed, we'll become more hardworking. So in this example currently, um, anybody can call this account to do whatever they want to. So it's totally not secured. So first, this is what we are looking in. So we have, okay, not clickable. Let me go to the node module. So we have the interface of an account, and this is the very important function that must be in an account. Verify user operation. So this is the function that the entry point will call on the account and ask, hey, a key is trying to perform an action. Do you allow this key to perform an action? If yes, then the entry point will proceed with the execution. So we could just look at this in our leisure time. Must validate caller is the entry point. Must validate. Okay. So this is just like dev um documentation. So the first thing is that it's trying to tell us that whoever is calling this validate user operation must be the entry point. Secondly, then it validates the signature that has been sent in. So remember from our schematic, the user operation first goes to the entry point. Then if there's a paymaster, it will talk to the paymaster before talking to the smart contract. So let's imagine there is no paymaster now for this our example. So the entry point now is talking to the smart contract directly, and the smart contract is paying for their fees by themselves. So with this now, this is what the entry point does. Once it gets to user operation, it asks the smart contract wallet, hey, I have this operation. Do you permit it? Then when it sends that message to the smart contract, in the blockchain, we always verify, we don't trust. So the smart contract is going to say, who is this calling me, sir? Is this the entry point? If it is the entry point, then to go ahead to perform that execution. So that's for that. So if you just look at this later on, so this is the most important function that's that an account must have. It's very, very important. So we'll go back to our simple account again and stay along. So we have this function here. So remember, smart contract accounts just have a one must have function, but we can add more functions into the smart contract account, as many as we want, and build something so crazy. And like that's the power of the programmability of this model. So this is just an example we use to test that our execution is going. So let's proceed. So first, we instantiate this is the owner of this account. So this address must be the person to call this account before this account will respond. So this is just a state variable that we're using to say, okay, what we are working on is working. So it just holds a value and increments it over time. So as we call in a user operation to call this, it just does that over time. So that is all about this account. Then remember this function, validate user operation. Remember what we said earlier on. It would take in the user operation, verify that that this is coming from the entry point and verify the signature is correct before returning 0. So ironically, when it returns 0, it means it is valid. And when otherwise 1 and the rest, it means the signature is wrong. So we can go ahead to test this out, but we'll wait a little bit. Let's talk about the factory account. So the factory account is just responsible for creating this account. So when, let's say, a new user, let's say this wallet, this kind of wallet system infrastructure is built for a company that onboards new users. And whenever the user is coming in, if this user does not have a wallet, auto deploy a wallet for this user. And two, whenever this user come in, for the first 10 days, I want to handle the gas fee that this user is going to spend using my product. So all those, the logic to deploy as this user is coming in is going to be done inside this this contract called the factory. So that is exactly what the factory does. So let's just look into it a little bit deeper. So this is where we have this instance of this account up here. Well, we name it account. We use new. So if you're new to Solidity, the new keyword just is used to create a new smart contract, a new instance of a smart contract, and it returns the smart contract glued or bounded with the address. So remember, we have this thing called a constructor in this account that takes in an address and sets this address as the owner. So we are going to still pass that in, okay, and we're taking it as a parameter coming from the entry point. So after we create the account, we emit an event just saying, hey, the account is created, and we typecast this contract to the account so we can return to the user console.log it and do as we please. So this, in creating accounts, just like a side note, there are 2 ways to create accounts, 3 ways to create accounts in Solidity. But we'll talk about just these 2. We have the create and the create to. So you could just read about the create and create to. So with create, it just uses the nonce and the address of the caller. So this is a bit deterministic, but not very deterministic. It's quite hard to determine where a contract will be deployed to before it's being deployed. So the create to just makes it a bit flexible, where you just have a salt and the bytecode and one other property, and that is, you can just pre-generate where the address where a contract will go to. And lastly, if we just want to read about this, we can just read about create 3. So create 3 just introduce the concept of DNA. So giving the factory of a contract the power to know, or giving anybody the power to know that, yes, this child contract was deployed by this factory. Just the way you can go to the hospital and take a child and a father and say, okay, from the DNA results, it is proven that you are this child's father. So that is what the Create 3 tried to introduce, and it's have its own utility. So we could look at that in our leisure time. So I think that was going to round up what we'll be talking about in the basics of this reintroduction to this the smart contract account. So the next thing we'll be looking at is deploying this to DevNet, not DevNet, testnet. Okay, not testnet, my local machine first. So this framework currently is Haddad, and we can run an instance of the EVM locally. So with this code, so with this now we are running an instance of EVM, and we can test all the instrument tests locally before we go to testnets, which is a bit slower than production mainnet. So with this now, our mini immature blockchain is running. So we can now start looking at our scripts, and would start. This is a fresh environment. So there's no, remember from our schematic, user operation talks to the entry point talks to the paymaster. If there's a paymaster, then talks to the smart contract account. So in other words, we need to deploy our entry point first in this our environment. So just see this as a clean slate of paper. There is no entry point, there's no contract in it, it's just new. And we just want to just look at it from scratch and see how everything plays about. So in order to do this, we'll be needing this scripts, deploy entry point. So we are using the Haddad framework again. So this is how we deploy contracts using Haddad. So this should be version 6. All right, yeah. So first we get what we call the contract what's it called, factory, and the contract factory just holds the interface of the contract, that's the ABI and the bytecode and the init code of the contract. With these three things, with just the bytecode and init code you can deploy, but you need the ABI also for the verification process. But with that now, we can deploy the entry points to our local node. We get an address, save it somewhere, and continue our test. So this line just goes to our artifact. So this is our artifact. Goes into here and it goes into the artifact in global and recursively look for a contract called entry point. Gets us the contract factory so we can deploy the entry point. So this is what this does. Get contract factory and deploy entry point. So when this happens, this returns to us the hash of the transaction. But we don't just want the hash. We want to subscribe to a stream that would wait on that hash and wait till that hash is mined and like added to a block. So that's what this does. And we just print out the targets. That's the address of the contract. So that is for this. So we'll run the script now. So in Haddad, to run scripts, you could just use this. You just walk through the directory with me. We have this folder called scripts, and inside the script we have the scripts you want to run. So first you then put in Haddad and a tax called run. So Haddad have this concept of taxes. So with that, you can plug into the Haddad runtime environment and do some crazy stuff easily. So it's just a way to just automate. You can use it to automate your deployment process. You can use it to automate your contract verification process. It just gives you superpower and it gives you access to Ethereum, give access to your contract artifacts, and ideally that's almost all you would need to um, to do many stuff in smart contracts. So next thing, we'll then specify the path to the script. So, and this part of the script is scripts. That's this guy here. And remember, we want to deploy the entry point. So we have the entry point. So normally we would have specified something like network. I'll place it to the network we want to run it. So ideally here it's local network we want to run it. That's localhost. But in the hard hat config, it has been done for us that whenever we are running and we didn't specify the network, should treat it as though we want to run it on our local network. So once we invent the wheels, we just use it that way and hit enter. Oh, sorry. So I placed in this network and I didn't pass in the corresponding data it's used to get the network. So sorry about that. And this should be deployed now. So we have our entry points deployed. So this is one cool thing I like about running this locally. You can see what is happening in the get clients or the execution clients real time. You could see the contract was deployed to this address. This was the transaction hash. Then it's shifted this address. And if you use Hadat a lot, you know that this is the first signer in Hadat, and it costs almost zero gas. It's very, very small gas that I couldn't estimate it in such manner. So this is the gas it costs to estimate the transaction. This was the block hash. So now we have our entry points deployed. I remember from our diagram, from the entry points to the user and the user operation goes to the entry points to the paymaster. If there is a paymaster, in our case right now, there is no paymaster. It goes to the accounts next. So next thing we need to do is to remember we have this in our account. Sorry. We have this called a factory. So in this our environment now, there is no smart wallet deployed. Yeah. So there is no smart wallet deployed currently in this our environment. But we want a smart wallet to be deployed if there is none. So how are we going to deploy this smart wallet? It's not magic. So we need a factory that's going to be that'll have the role or job to deploy smart wallet if there is if the wallet does not exist already. All right. So we'll be running the scripts that will be deploying that next. So yeah, I thought about the scripts. I thought I didn't. So we'll look at the factory script now. So remember how hard that works. It goes into the artifacts, gets the contract we want to deploy, get the contract factory. That's like the contract I want to deploy, the name of the contract that we're going to place in here. Then it gets the factory of that contract type and deploys it. So the next thing we do, we wait on that transaction hash that's tied to this object here, and we print out the transaction, the account, not account, sorry, the address of the contract. So Next up now is to run this factory script. So remember how that works. We use yarn, that run the location or the path to our script that we are trying to run. So, and that is in this case, deploy factory. So now we have this. So if we run this now, it will deploy our factory for us in our local dev network. So from our local dev network, we've seen that yes, this has been deployed and it was deployed to this address. So now before we go for that, I didn't give you the scope of what we are trying to test. So this is scope of what we're trying to test. First, deploy the entry point, deploy the factory. After deploying the factory, we want to create a smart contract account. Create a smart contract account and execute this function. Execute using our smart contract account or against our smart contract account. So that's the scope of what we want to do. And this is checked. This is checked. We deployed the factory. Now, I want to deploy the smart contract account, but I want to show you something, something a little bit tricky in this script. And this is a script handling this functionality, account execute. So before I go further, is there any question? Yeah.
No question on the chat. Guys, if you have any question, please kindly, of course, indicate, raise your hand, and you'll be given the floor to ask your question.
All right.
Mr. Sheon has a question. Mr. Sheon, please go ahead. Please unmute yourself. Yeah.
Good evening, everyone. Good evening, Chair. All right, thanks a lot for these explanations. When I was trying to run the smart, I composed a smart contract. If you remember, a few days ago when I encountered some issues about some codes. When I tried to run the smart contract since I had that, and the folder that I created, all right, is of course is a script. So what I did was I said I use npx hard at / scripts script / deploy.js, because that's the file name, deploy.js. But it was just giving me a lot of issues, and I think that was my first time on actually trying to run that. I believe I didn't get some things right there. I don't know if I have to share the code with you to understand what I'm saying, but I know you get the point, because initially it worked, but later on, because they're supposed to give me a hash actually, but it didn't give me any hash, and then I tried to run it again, and then it brought that error that it could not identify script folder.
Okay.
So
Okay.
I don't.
Okay, basically, it's hard to actually debug what you're saying. I'd advise you look at your HADA config file, and make sure that you've enabled it so that you can run the local your local host, as in the local hard hat nodes. And um, just check your hard hat config file, and then of course, if you're still having the same issue, do reach out to myself, Uche, or Mr. Enoch on Telegram, of course.
All right, thank you very much. I'll do that.
All right. So please go ahead, Mr. Uche.
All right. So yeah, just do that. So the next thing we're doing now is creating the account itself and executing a contract using these accounts that we created. So remember, from the entry point, it's going to like when you are sending a user operation, remember this field that we looked at. Close that. Okay, this field called init code. So if it's empty, that means, oh yes, this account already exists. If it's not empty, then with the code inside, exactly, if the account is not deployed, it will use this init code to talk to the factory contract that we deployed earlier on to deploy the account. And that's what happens there. So we'll run the script in a bit, but this script is quite big, and I want us to like get what's happening in this place. So first, you see, we have placed in the address of the entry points. I've placed in this already, but ideally it's just going to be, we come here, we copy the address of the entry point to be logged out and place it in here. Then we come here, take the address of the factory, we place it in here. So now about this nonce of one. If you know smart contracts to a large extent, you will know that if you do Ethereum to a large extent, you know that none starts from 0. But for a contract, remember, we are not dealing with just an EOA, we're dealing with an address that has code within it. So for such kind of address, it's not starts from 1. That's why we have the nonce 1 there as the factory nonce. And because we want to, like, remember what I said earlier on, we want to know the address that a contract will be deployed to. We want to know the address that this contract is going to be deployed to. And you see, we're just using new. We're not using create to. So that means we're using just the ordinary create. And it's going to make use of the nonce plus the image of sender, that's the ABI encode path of that, then hash of it. So that's now going to give us the address that this will be deployed to. So where's our script? Yes. So that's why we need this none. So let's proceed further. So first thing we do, we get the signer, default signer, that's F63 guy, F62 or something. We get that signer, we get the address of that signer, so we can use it instead of using signer.address everywhere. Then we get an instance of the entry point contract. So, and this is how you, from the name, attach an address to a contract type. So this is the contract name. We go to the factory, we get this contract name. So this is just what it just called an interface or a contract factory. So then you just do dot attach or dot connect the address of that contract, and we just use as entry point. So whenever we are using this, we can have good intelligence. We can do stuff like entry points dot, and it's going to like list out functions in the entry point. This is just something nice to have, especially when you're using TypeScript, so you can take advantage of the types. So the next step, we have the account factory. So we get the instance of the account factory. So this is also an address we logged out here. So yeah. So next thing now is we want to get the address that this contract we're trying to deploy is going to be deployed to. So it has just provided this utility to create address. Remember, from our previous discussion, when you use new, you are using the create opcode to deploy the contract. So we use that same create it has just used that same create specification to generate or to pre-generate given the nonce of this address and given this address, what would the contract or which address would the next contract this address will be created and be deployed to? And we want to know this because we want to know if an account has code before or if not. This is a kind of a very, 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 very not a good way to do this, but it's just a demo stuff because we can't use the script 2 times. If you get what I just said, very good. If you don't think about it so much, it's not so necessary. But let's just focus on the demo. So we get the sender, this is the account, this wallet will be deployed to. Remember, the wallet have not been deployed yet. So we get this account to be deployed to. Then we're going to check, does this account has code? Remember, Ethereum is a global state, a global state machine, and given an address, a memory slot, a 2 bytes string, we can know if this address has value that it has, the native currency of Ethereum, or if it has code. So we are going to use that method to get the code of that contract. If it is greater than 2, and why we're using greater than 2 is because an empty stop, this is going to return a string, let's say. So an empty string that it's a byte, it's going to be this. JavaScript is a bit shitty when you're dealing with bytes and some kind of types. But just take it that way. This is how an empty string is going to be like. And when you like check the number of these characters, it's 2 characters that is this. So whenever the character is greater than 2, that means there is code in this contract. And if there's code in this contract, we don't want to deploy this contract again. Else, we deploy. So how we're going to do that is, remember, we said, I need this first. Remember, we said if this is empty, if we don't pass in anything as this parameter, that if we pass in OS using JavaScript, it means this account already exists, don't deploy it. But if we pass in something else, it means before you validate this account, before you simulate from the entry point, before you bundle and do your simulation, first in your simulation, deploy this account, then you can use this account to perform the rest of the operation. So that is the check we're having here. So initially, we are imagining you don't want to deploy as the default state. Then if this returns true, so that if the length of the code in this address that we got is greater than 2, then we're going to deploy the contract. Okay. So we're going to deploy the contract. So this is how the data you will pass in to the init code looks like. So first, we want to pass in the address of the factory. So it's from the specification of this So let me just give you this GitHub. Yeah. Okay, just uh-huh. So this is also a good resource to have. So this just hold and just go to this repo in general. And just look for all the host verification in this in this organization. So that's where they specify if you want to build utility tools for ERP 4337, you have to read the specification and know how to build it. So that aside, so this is how they specify you pass in init code. So first, you pass in the factory address. So that's the address of this contract we deployed here. The address of this contract. So pass in the factory address. Next up, we'll pass in the init code. I remember in our init code, we just have one thing, which is to create accounts. That's this guy, this function, create accounts, and it takes in a parameter owner. So please follow me. So what we're now going to do here is in ethers, when you want to like encode a function parameter. So in Solidity, how you know a function you're going to call is first the function selector, then the arguments. So the function selector and argument. So with this and this, we can get with this interface now. With this interface tool in this contract type, we can get the function selector concatenated with the argument, which is in this case address 0. So this is what we're going to pass into our init code if our contract has not been deployed. Please give me a minute. All right, I'm back now. You can see my screen, yeah?
Yes, we can see your screen.
All right. So first, I'll have to really apologize. I'm having a class team meeting right now, so I would just finish up with this script and would continue tomorrow or next tomorrow. Really, really sorry about this. Sincere apologies. So first, the function selector. This night I'll drop a blog that explains how function selectors are picked in Solidity. So like giving a smart contract address, how does the EVM knows that, oh, this is the contract in this byte code, in this runtime code that I want to call, and this is the argument you should pass. And this is the length of the argument. This is what I'm expecting you to return. So all those are baked into the EVM, and as smart contract developers, it's our responsibility to know that. So I'll drop a link to a blog that explains that. And the more you dive into the EVM, the more solid it will become, no much more like a black box, because you know what's happening under the hood. So the next thing now is, since we know the since we can now programmatically determine to add in its code or don't add in its code or don't add in its code. If this contract is already deployed, we can now proceed with our main logic. So the next thing is, now we are going to get the account type, just the account type itself. So then we are going to then do this thing, encode function data. So remember, in this account, we have something called execute. This function does not take in any parameter. So remember, Ethereum, the way they encode signature is the function name, it's kind of the hash of the function name, first 4 bytes, then of the function name plus the types of the parameter in parentheses. So, but this time around, there is no parameter, so it's just the function name. And we'll just give it as just the function name and to help us get the encoded version, that is the 4 bytes function selector. So this is now the core data that we want our contract to execute. And given that core data, it should call the execute function and increase this count. So by default, the count is going to be 0. So giving a core data to call the core data for execute, is to call this count and increase our count stakes variable. So next up, now we have this function selector. Next, we want to get the balance of this sender in the entry point. So that's cool. And we went over this yesterday a little bit. So before the entry point would call any contract on our behalf, if we don't have a paymaster, we have to deposit some ethers, the native currency we use to pay gas fee, in the entry point on our name, recorded on our name. That's CO. I'll be making some calls later on in the future. When I make that call, the gas is going to cost. I want you to deduct it as post-paid due. Is it post-paid or prepaid now? Yeah, I think it's post-paid. I've paid you in advance. So that is what's happening here. So the first thing you then do, our script will first do, we'll go to the entry point and ask, entry point, do I have some credits in my balance? If it is no, and from the latest version of JavaScript, we don't need to use like ethers.js, fast and other stuff. We now have access to big number. So whenever you just put in n after a number type, it's taken as a big number. Just a side note. So if the balance is 0, that means we don't have any money, need to deposit some money. And because we are very rich in our dev nets, we have about 10,000 ether. So we are going to graciously give our entry point 100 ether in our name, so we can perform other transactions later on. So now we've paid for our transaction, and our future transaction for 100 ether is around $300,000 right now. So the next thing we're going to do is create our user operation. So remember, the entry point, the user operation gets to the entry point, and the entry point calls the paymaster. If there is a paymaster, then if not, it calls the smart contract account. So we are creating this entry point. So that the address that our contract will be deployed to. Remember, we already know that already because of we hashed our factory address and the nonce together, and we got that data. So Then next up is the init code. So with the init code now, we will be able to create this account because this account does not exist at the moment. So now first, nonce. So for nonce in EIP 4337, nonce is managed by the entry point. And nonce is not just nonce is just, as we know, is like increasing order. As you perform a transaction, as your nonce is 0, the next nonce will be 1. The next nonce will be 2. Next nonce will be 3. Just ascend until infinity. Then, but accounts with this EIP 4337, it gives us the power to reorder transaction priority by just switching the key here. So when I switch this key here, my nonce is something else entirely. And this will just give me the power instead of my transaction just waiting in the auth pool, and I need to maybe do some arbitrage or some flash loan before this other transaction happens. I could just increase the nonce and send it, maybe pay much more higher gas fee, and that executes first, and my transaction goes as I ought it to go. If what I've just been saying now is gibberish, don't worry, you'll get that later on. But just look at it this way. It just gives you the flexibility to play with your nonce. So so what do we want this contract to do? Remember, we want this user operation to do. We want this user operation to go to this account, call this function, and increase this count. So in other words, after this test, we want to see that our account is moved from 0 to 1. That's the aim of this test. So back to this. So then the next thing is gas. So because we've placed in so much gas, we can put in anything we want here, but ideally we would estimate this gas before we call this. Though this is not in the scope of what I've done in like the entire scope, but I guess it's something we can look at in the future. Then the verification gas. So whenever the entry is calling this function, verify user operation, this function is completely custom to the developer of the smart wallet. So they can place in anything. They can place in some functionality to validate a BLS signature in there. They can place in some functionality to validate some kind of elliptic curve that we've not. They can place in functionality some things that is quantum resistance in here. But the smart contract wallet wants to give you flexibility to determine, okay, once the gas is getting too much to handle the logic in this verification, I want you to take me out. And remember, when before the transaction is run, it's going to first do something we call estimate gas. So this estimate gas would run the transaction in a sandbox without changing state and tell you this is how the gas, this is what you pay for the gas, and your transaction would be successful. So if the transaction will not be successful, it will not be sent initially, unless it was sent. So in that case now, if the gas that will be paid here is too high above what I intend to pay, I want you to take me out. So that's why this parameter is here, just to give the wallet owner, the wallet developer flexibility to handle their gases. The next one is the pre-verification gas. So before the entry points call the validate user operation on our account or execute, validate. So some things can happen in earlier on. So things like talking to the paymaster, transferring tokens from the paymaster, the entry point, maybe performing a unit swap functionality to swap my USDC for Ether, then use my Ether to pay for gas. So all this functionality, it could be quite big, and some paymasters could just place in some wicked logic that you don't want to pay for, or they can place in some logic to perform some things on their own behalf, and some crooked things you don't want to pay for. So you are now putting this here, saying that if the execution is now passing 50,000 GUI. That's 50,000 gas units. I want you to take me out. So now the next thing is max priority fee. So this came in from the EIP 1559, I think. Yeah. So if you look at this, so this just stabilize the gas, what I'll call the gas curve. That's how gas is determined even in high demand. So gas don't just skyrocket, skyrocket. Gas don't just go up without bounds or not without bound. Gas doesn't just go up unpredictably. It's more just like a linear graph, not like an exponential graph. So that's what this does. But this mass priority fee just okay, this mass fee per gas just like how much is the max stuff you want to pay. So this one is now the priority fee. So this is how you incentivize the miner to, hey, pick my transaction before you pick this other transaction because I'll be paying you more to pick my transaction. So that's for this. So now the paymaster data, you see, it is OX in a string. And this just represents an empty byte. So this just represents an empty byte. And that means we don't want to do anything paymaster related. And see the signature empty. This is very, 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 very bad. But because we are lazy now, it's empty because we are not verifying anything. So it's useless either way. So but later on, it's going to be a signature signed by our MetaMask or something of that sort. So this is also an MC signature. So the next thing is we want to tell the entry points, hey, take this user operation, handle it. And this is the address sending it to you. So the entry point is then going to perform the validation, talking to the paymaster and perform the execution in general. That's like talking to the calling that execute function that we had earlier on. So here we wait for the transaction to get the hash and print out successful. If it's successful, then the transaction hash. So, but I want us to draw our attention to what we've been learning so far. You can see in this whole system or in this whole playground, we didn't talk about the bundler. So we didn't talk about the bundler because we are in our test environment and setting up a bundler like this guy. So where is this slow? Come on. So this is an implementation of a bundler. So remember from what we've learned last week and from Monday, Tuesday, and okay, I will not talk about that today. A bundler takes all the user operation and sends it to the entry point. And we don't talk to the entry point directly. We want the bundler to talk to the entry point on our behalf. So with this now, with this in this our case right now, we don't want to bundle anything because we'll have to run a bundler like this guy to do that. But we don't want to think about that. We just want to build our smart contract wallet. So we'll be sending it directly to the entry points to handle. That's our user operation straight to the entry point. So with all those talks, we can now run the entry point script. And that is the account execute. So this ideally should go in, execute, and return to us a hash. But we are not going to any Explorer to do anything. So there's no need for that. So this is the address of our contract account. So we need to do this, but I've done this already. So now we need to like place in the account that we want to call. to tell us, okay, what's the current count? Remember, the goal of this little test is to see that the count have increased from 0 to 1. So now we want to find out. So we'll just copy this and paste it in here. So it's the same thing because I've run this test before. So we want to now call this script to read what the count is currently. And if the count is 0, that means we are not successful in this voyage. But if it's 1, that means it got to this contract, that our account contract, and made a call to this contract using account abstraction. So let's run this script real quick. And moment of truth, yes. So we have 1 here. And in other words, our setup is complete. So this is what we're scoping tonight. I am already very, very late for something. But from tomorrow or from our next class, what we will first do is to explore deploying this on testnet, but not just deploying on testnet already. We'll just talk about the paymaster, then talk about like sponsored transaction, then we deploy to Arbitrum, and after deploying to Arbitrum, then I'll pull in this other contract. So this contract already has an implementation of social recovery. So from this contract, we'll code out live on the call, the social recovery implementation and the dead man lock implementation. And if time permits, we'll write a test script to test that it's working fine. And that would close in this series. So I think that's going to be it from me. Let me just drop this link also so you could look at it later on. Yes. So yes, that's it from me. Thank you very much for having me. I'm sorry again, I have to leave without finishing the task. Really, really sorry.
It's fine. It's fine. Thank you very much, Stucci. Of course, it was a very entertaining and educative session. Myself, I know I learned a lot, more concepts. The thing with blockchain is you always have to keep improving, expanding that knowledge base, and of course, learning never stops. So, of course, I have learned a lot, and but then it's not really about me today. It's about all our wonderful participants, our viewers online, and of course, those of us that are here on call. If you have any questions, like we always do, if you have any questions you would like to ask, please do raise your hand, and of course, you'll be called upon to ask your question. Or if you feel more comfortable putting it in the chat, you can always go ahead and put it in the chat box. So thank you once again very much, Trey, for that enlightening and of course, very, very powerful session. You broke down all the concept and of course, it's very much appreciated. So thank you very much. I'll just look at, okay, so no questions from anyone? All right, all right. So guys, always remember that you always have access to this resource. It's out there on our YouTube page, YouTube channel, of course. Remember, if you go to our YouTube channel, you'll find tons and tons of resources on the blockchain and of course, things that help you dive deeper, move further in the blockchain space. So, and also do remember to follow us on Twitter at Ethereum Nigeria at It Lagos, and then also follow us on LinkedIn at Ethereum Nigeria. Of course, if you are not part of our community, please do well to join our Telegram, of course, and also our Discord, right? So of course, we are keen on providing you with all the right resources to actually. Okay, wisdom. Yeah, you received your bounty from yesterday. That's awesome, right? So, like I said, we learn, we earn, and we grow together. And yeah, that's that for me. We also have our lead in the house. Remember, today is the last part of our series on account abstraction. But then, because of time, of course, this series we are going to have more resources which we are going to publish on the YouTube channel. Of course, the complete part of these sessions, will make resources on that, and then we are going to share that on our YouTube channel. So do well to check out our YouTube channel, and of course, yeah. So guys, remember our event for Saturday is going to be wow. Of course, there are other bounties to be won on the event on Saturday. Uh, yeah, the venue for our event is Unilag. Of course, we are going to send you guys the invite. And of course, even if you are not in Lagos and you know someone who is in Lagos and of course passionate or enthusiastic about the Web3 space, of course, you can always share the link with that person, of course, and the person can come forth and um, of course, benefit from this wealth of resources. Please also follow us on Twitter and retweet our posts. It goes a long way. We're trying to reach as many people as we can, right? So, of course, we need your help as a community to do that. So please always retweet our posts and feel free to always comment and share it on all your groups. Of course, you don't know who might be looking for an opportunity like this, right? So you have this opportunity. You can always share with every one of your contacts just to bring them up and onboard them into the space. And of course, we know on the blockchain space, there's a lot for everybody. So yeah, so that's that for today, guys. See you guys on Saturday, and do well to follow our social media, retweet our posts, comment if you can, if you must. Then, most importantly, if you're not part of our community, do well to join our Telegram or Discord. And then, if you have any questions, any clarifications you need, you can always do well to forward your question to on Telegram, of course. And yeah, if you're in Lagos actually and you would like to volunteer for our event on Saturday, please feel free to reach out to our lead, Mr. Enoch, on Telegram. You can also reach out to me. Feel free to reach out to us, and of course, we'll onboard you. We'll be glad to have you, right? We'll be excited to have you. So, yeah, that's that. This yeah, wisdom. Yeah, you have to be in Lagos. It's an in-person event, like I said. But even though you are not in Lagos and you have friends in Lagos, of course, you can always, of course, tell them to join our meet on Saturday at Unilag. We'll share the link with you guys later. Of course, try to bring them into the blockchain space because it's wide, it's enough for every one of us, right? So yeah, it's an in-person, but you can actually volunteer remotely. Yeah. So if you're thinking of course, volunteering in the community, of course, you can always volunteer remotely. Any location you are in Nigeria is fine. Of course, you can always volunteer. You need access to internet and all of that, but then you can always volunteer remotely. So yes, for every other inquiry, please do well to reach out to myself from Stenok on Telegram or Discord, and of course, yeah, would respond to you swiftly. So thank you very much for your time, guys. And then, yes, see you on Saturday. I can't wait to be there. Yeah. So because I know it's going to be entertaining, it's going to be a lot, right? There's a lot of goodies on ground. There's a lot to be learned. There's a lot of hands-on, and then there's a bounty. So it's quite interesting, right? So see you guys on Saturday, and good night, everyone.